All right, so in this lesson, we're going to take a look at our wireless maps and wireless heat maps, and we're going to have some fun. This is actually a pretty cool area and feature for Catalyst Center, but there's also some real world reasons why we need this. So for those of you going, well, I mean, are maps really that important? Do they help me out? In a large enterprise environment, you really need them for a few reasons, okay? Troubleshooting, asset tracking, uh, verifying RF coverage whenever you're not at a site, but just need to see what's going on with the site. All that kind of fun stuff comes from having these maps configured correctly. They need to be calibrated. APs need to be placed correctly. So in our topology, we've got our McGregor office, and I actually added a third access point on this controller for a couple reasons. I wanted to make sure we had some good visuals whenever we're doing the heat maps, because one of the most challenging things to show people with Catalyst Center is the heat maps, because the data we're going to be looking at isn't real. You know, the APs are right next to each other. They're not placed throughout a facility. Although I was thinking like, hey, why don't I just replace all my APs in my house and use my house as a facility? But I never got a chance to do that. Time is the enemy kind of thing. All right, so I've got a few APs here. In a previous lesson, you would note that these were previously assigned to a floor. I removed them from the floor assignment because I wanted to show you from the beginning what you have to do for these heat maps to work properly. So we're going to go ahead and select 9K AP1, the EWLC, and the Flex. These are all named differently from different labs we've done. And we're going to click Assign. And once we're on this, we can choose Assign All and then start breaking down our floor area of where we want it to go. So this is McGregor, Central Texas office, and main floor is where these will be assigned. And we're going to click Save. Notice they all came up with that assignment. So next. And this is on a controller that was not provisioned with Catalyst Center, meaning we didn't deploy the WLANs with Catalyst Center. It was just the first controller I had configured for visibility. It's been managed by Catalyst Center, but we didn't use that integrated workflow. So we're going to go ahead and do a preview, get these guys assigned to that floor. The other thing you can do is go to the floor and import the APs that way from the design and hierarchy, but this is the way I prefer to do it, is through this method. Now, if you had, and I'll show you this in a bit, but if you had deployed your wireless controller with Catalyst Center like we did on our Dallas office, then whenever I provision these APs, they do inherit settings that are assigned via those network profiles for that site. So just keep that in mind. But now let's focus on this for now. Let's go to design and let's go to our design hierarchy. And I'm certain our task is going to complete pretty quick. And we're just going to jump over to our Texas facility. As you can see, I'm getting a nice map now that is built by Catalyst Center that kind of breaks down our offices right in Texas. And we're going to go to our Central Texas HQ, and we're going to go to our main floor. Okay. So in our main floor here, it starts off, and here's my heat map, right? Or that's my legend anyway, to say, hey, this is neg 90 and that's neg 35, which would be great, but I don't have APs here, right? So there's a lot going on with these maps, guys. It behooves you to spend some time to learn the way these maps operate, okay? Now, I can do this if it's a production deployment. I want to make sure that I've imported this floor and I've got the correct dimensions, size, the thickness, all that kind of stuff. So if it's floor type, what's the thickness of the floor, what's the width, what's the length, all that kind of good stuff. Now, one of the things here, okay, is that we want to set the scale of the floor, okay? So I need a good base point of measurement of what the actual floor dimensions are. So one thing you can do for a lot of places, if it's in the US, is click on a door, and from basically doorknob to doorknob should be about 2.8 to 3 feet. So that's what can help you get the scale, and that's what basically was used for this. I guess I set the scale before. You should definitely measure a wall with a measuring tape, laser. Your iPhone can do it nowadays, whatever. Get some unit of measurement of length to set your dimensions properly, and that will help you with your floor dimensions. especially if you're going to use Catalyst Center for predictive designs and do overlays and all that kind of fun stuff. We're not focused on that right now. So I would have a design before I even started this. I should have had a site survey at the site. This is a very small facility, so maybe it was virtual, but of where I place my APs and where they're going to be, right? This is a lab, so the data is not going to be exact, but you will be able to see what to do and how to do it. So these are unpositioned, assigned to this controller. And you can see the AP models there. So if I've got this line there that I'm at 9136, and if I've got this color, I'm at 9120 basically, right? So now I've got my APs, and I just need to click on them, and then I say this AP is here. Then I choose the next one. I say this AP is here, and this AP is here. Okay. Now there's some settings with each AP if you didn't notice. So if I click on that, it says, hey, APs here. I've got internal, if I have antennas that I need to choose, or if I have settings or anything like that, I may need to tell the AP about it, because the AP is configured correctly, right? So we've got options with some of our, especially external antenna APs, right? But for the most part, with these indoor floor maps, we're focused on integrated antennas. Make sure they're mounted properly, all of that kind of fun stuff as well. So we make sure whenever we do our surveys that we hand over an installer guide that says this is where the AP is going to go, it's where it's going to sit, this is how to connect it, this is how to use your T-frames or mount whatever type of mount kit you've got. This is how it should look. It should be a completely professional install, not just thrown up quickly and here you go, right? But take the time. They should all be orientated the same way. So, if you're orientating to the north or whatever it is, just keep it consistent throughout that site, throughout that enterprise, and especially throughout the floor, so that everything looks nice and neat for the deployment. But once that's done, then I've got where my APs are, and something very important just happened, right? Until now, APs, what if I've got a 10-story building and I've got APs on all floors? We've got all this new technology now that says, hey, APs can share neighbor tables, for example, and say, hey, here's the APs you should roam to speed up roaming and all that kind of fun stuff, right? But how do they know which APs are on the same floor if I haven't told them that, right? If I just have all the APs on a controller, but I haven't went and placed them on a map and said they're all together on this floor, I have no ways of knowing, because APs can hear each other between the floors. So I might be telling other APs, I might be telling my clients, hey, go to these APs that are on a different floor, unless I have a way to say that they're all together. And once you do that floor assignment in Catalyst Center, is a way to tell the controller, these are all assigned to that same area. These are all assigned. Now they also do some RF stuff to figure that out, okay? And it's pretty good. So in other words, typically if I'm between floors, I'm going to have a lot weaker signal than the APs I'm on the same floor with, but not always. It does get tricky sometimes. So this is our basic heat map. And with it, what this is supposed to tell me is how well my coverage area is for the building. So if I had users up here, probably wouldn't be the best coverage area, right? But I can tell you, interestingly enough, these APs are not far from each other in the same rack and data center. So this coverage that it's laying out is very interesting, because they're really pretty close together, right? Now, I can change my view here, and I can go between channels if I want, 2.4 and 5 gigahertz if I have 2.4 enabled. I don't think I do, because you can see those 2.4 are not being used right now. You can also do 2.4, 5, and 6 to see what's enabled there. And so I can start playing with my views to see what different views look like. We can also adjust our sensitivity, right? So if I'm looking at all that, yeah, it's going to say, hey, I've got this entire place blanketed with 2.4, right? Because I can cover all this area, because that's how well I'm hearing each other. If they're that far apart, we're covered, we're golden. So like I said, the data is not going to be valid right now because of the way we've got things built. Okay, this is not real, but it's a scenario. So, and I should see things getting worse Orange is not bad. Okay. One of the biggest mistakes people make is they keep dropping APs until they get a green map. Okay. That's not what you want to do. Clients should know things are good and things are getting worse. So having that scale across is not a bad deal whatsoever, because my client's going to figure out, hey, things are getting worse. I should start looking for a place to roam, all that kind of fun stuff. Now, I've got some options for viewing things in here, right? So if I go to my view options, I can start adjusting map, opacity, but also maybe I want to cut off. I know neg 65 is my kind of golden standard for good voice and video calls. So where am I going to get a neg 65 dBm in this facility? Well, that looks a lot different, right, than that neg 75. Now, even if they're close together, right? So you can kind of start playing with this and seeing what the coverage should look like. But if your map's not calibrated, it's not going to look right. If your APs are not placed properly, it's not going to look right. So put good data in and you will get good data out. That's the moral of this story. Okay. We can also change and do contour coloring, or we could do gradient. Contour is just, it's a very simple coloring scheme: green, yellow, red, right? So you got that right around the AP. We're green, then it's yellow, then it's red. I like the gradient color schemes best. There's a legacy one. If you're used to Cisco Prime infrastructure, the legacy color scheme is here. That's what Prime infrastructure used to color everything. So that's why they call it legacy, right? Mm-hmm. So the natural is the one that's more common nowadays, or I like it better, but it's up to you. Now, I've got a lot of other things I could view here, guys. That's what makes these maps so cool. So one thing I care about is, okay, the coverage looks like this, right? And I typically leave this around a neg 70, right? Just because that's a more realistic representation if the data was real, okay, of how clients are experiencing things. I'm not guaranteeing a great voice and video call at neg 70, but it typically does work fine at neg 70 as long as SNR channels and all that stuff are in place. Now, what else might want to see as a wireless engineer, right? Well, I want to see a lot of stuff. Okay, first of all, the coverage is one thing. So this tells me where clients should be getting good coverage and should not be. Doesn't mean clients will not work moving from this AP to this AP, by the way. Okay, they absolutely may work doing that. It's just saying, check that. If there is problems there, this heat map could tell us there's potential problems there. Also up here, there's no coverage up there. So clients may not be working well up there, right, with these parameters. But I can also see sometimes, hey, there's going to be a lot of clients that are around this AP, and I see almost no clients connected to this AP. What's that about? Well, this goes back to the fundamentals of understanding channel utilization, DFS channels predominantly. There's a lot of issues with DFS channels, which is over half the channels in 5 gigahertz spectrum. So I may want to know which channel, my APs are on, right? That might be a good thing to know. Right now we're looking at the names, but we can change spectrum. So right now it says, hey, I'm on 36, and I'm on 44. So that's what I'm on right now, right? So you've got some options to play with here. What about power level, right? So I see this is the coverage you're doing. Is there anything we could fix for that? Well, we could change the power level or look at the power level. Now, you're going to have to go look up what Cisco power levels mean, because typically we're looking at dBm, right? Or we're looking at there's power conversion as well. So milliwatts, decibels to milliwatts, all that kind of fun stuff. So maybe I'm looking at I want to see channel and power level. So this tells me, hey, I'm on channel 36, power level 1. Power level 1 is the highest power level for an AP. That basically means it's trying to compensate with issues because there's not a lot of coverage in the area for this area. Okay, and RRM is handling that right now. So radio resource management, right? My controller is trying to compensate for lack of coverage. Basically, if I see all my APs at a power level 1 or all my APs at a higher power level. Now, here's the thing, right? I'm probably going to have some co-channel interference over in this area because if I look, these radios are, they're both channel 36. So now I've statically done that for a couple of reasons, but this is all stuff I could figure out real quick. Maybe I want RM to take back over. So if I go back to my APs here, and again, I did this because we're in a lab, right? And I needed to do lab things. Those Uni 1 channels typically are going to work better for connectivity whenever you're far away versus there you go. Come on. So I need to log in again. So that's what it is. Those early Uni 1 channels and Uni 3 channels are non-DFS. So those typically get discovered faster by clients and they work better for clients in smaller lab environments. But I shouldn't have both those radios set to the same channel. That's kind of silly, right? So I need to fix one of those guys. So you can see 3640, 3640, and these are, but it's the reason that we're having issues right there is because we're only doing 20 megahertz. Whatever it says, we should be doing 40 megahertz. So that is the interesting thing. Now, I could just set this to 44 and we should be off to the races. Now this guy is 44. So let's set this guy up here a little bit higher. And we'll go to 48. So that's static. Typically, guys, you're going to want, and these are possible second 5 gigahertz radios if you wanted to use them for that. That's beyond the scope of this course. We cover it all in the Cisco 9800 Rockstar and other courses, but some APs have several radios, right? These newer APs, they've got 5 gigahertz, they've got dual 5 gigahertz, they've got 2.4 and 6 gigahertz radios. So they're very capable, very powerful, right? We just don't have the 6 gigahertz advertising anything right now. But you notice I made a change, so you probably want to refresh the map and see what's what. And it may take it a bit for it to actually understand because I made that change out of band. Typically, we'd have RM making that change, right? So what I'm going to do real quick is we're going to go to provisioning inventory. I'm just going to resync that controller. Don't want to edit actions, inventory, resync. Again, this was not configured with Catalyst Center, the controller itself. We configured it out of band, managed by Catalyst Center. But hopefully you're getting the point. There's a lot of stuff I can display on my heat maps here. Now, you can take this even further, and if you wanted to see where clients were located or your endpoints or devices are located, if you integrate with CMX, Cisco Spaces, is one way to do that. And you can absolutely see visitor analytics, and you can see visitor information and where they're at in the map, and you can see their RF details, which is very useful for troubleshooting and supporting. Nowadays, you do not have to have a CMX appliance for basic location. You can actually just use CMX Spaces and get that location information. Very slick stuff. But I want you guys to take some time in your Catalyst Center, spend some time with the view options here and all the different things that I can show, okay? All of my different view options, I want you to look at it and see how you can turn, you see clients, they're not even on here because we don't have Spaces integration. If we did Spaces integration, then you would be able to start seeing, client details about that. Also interference, right now we don't have any interference. If I had 2.4 and 5 gigahertz enabled, we'd probably have some interference sources around, but to see where they're at on the map and everything, to see exactly where it's happening, you would want Cisco Spaces for that. So This is going to be just a bit, and we should see those channel changes that I did there. They're static, so it's taking a minute. There we go. So you can see this guy's 44, this guy's 48 now, this guy's 36. And if I click on the AP2, I get to see which radios are up, right? I can see this guy's up on 213. So I am advertising 6 gigahertz, but I don't really have anything advertised on 6 gigahertz. And if I had any clients, I don't have any clients connected right now. But if there were interferers, what those interferers would be, right? So there's a lot of details I can see like that from a support perspective that helps me dramatically. So that is why this is a big reason why Catalyst Center is so powerful. Now, getting to the bottom of power, remember how I said you really kind of have to be able to analyze the power output, right? So 17 dBm doesn't sound like a lot. 10 dBm is 10 milliwatts. 20 dBm is 100 milliwatts. You subtract 3, you're dividing the power in half every 3 decibel change, right? So that's 50 milliwatts that AP is rocking right now on that radio, which is pretty impressive. That's pretty powerful, okay, for what it's doing. You can see this guy is at a power level 2. And so what does that really mean for us being at a power level 2, right, on the radio? So this guy's at 20 dBm, so that's 100 milliwatts on his B radio. And if I look at his A radio, that's a lot lower power. So that one's turned off. This one's at 2 dBm. So very, very low power there. This guy, let's see, also 5 dBm. So a little bit more power. And it also depends on channel that's in use and all that kind of fun stuff as well. But I have, if I'm supporting something remotely, this is what gives me the intelligence to be able to properly do that and figure out, hey, could it be coverage related? Guys, I'll tell you this though. Let me just recap the heat map thing with this. First of all, make sure your maps are in here, make sure they're calibrated, make sure your APs are placed properly. Ideally, if you have Cisco Spaces, do that integration so that you can see your client layout. For troubleshooting, make sure your help desk has access, view-only access to your maps to see where clients are and what's going on with them. And make sure that they've got access to assurance for troubleshooting as well. There's endless amounts of intelligence that can help people with. Get to the answers to any troubleshooting problems very quickly, okay? You can give your help desk read-only access and then have a good escalation plan. But I'll tell you this about Wi-Fi. If you start with proper site surveys and a proper RF design, and you have a team like our team at Active Expert do your surveys, and they tell you this is where to place your APs, and you follow those recommendations, and you have us consult with you on here's how to deploy your controller for any type of environment, you can take, is it the Wi-Fi, out of the troubleshooting equation. You already would know it's not the Wi-Fi. You can go on down the list to the next thing, and that's a massive deal. That's what we do at our parent company, Active Expert. We take, is it the Wi-Fi, out of the troubleshooting equation. It all starts with proper planning and design, proper build out of our controllers, and the settings for RF and all that kind of fun stuff for the environment. Once that's done, I can start looking at other things for the troubleshooting equation, or better yet, reduce the drastic number of tickets coming in for troubleshooting Wi-Fi. But make sure if you've got the tools, they're set up to work for you to give you the intelligence so that you can properly support these modern enterprise environments. So this was a little bit about the maps. Again, get in here, spend some time on it, play with it. Hope you enjoyed it.